New deep images hint that interstellar visitor 3I/Atlas has sprouted a faint anti-solar tail, just as JWST confirms a CO2-dominated coma and the VLT reports nickel emission without iron. What's driving this bizarre chemistry and geometry, and what might show up as it dives toward the sun this fall? On August 27, Gemini South Imaging (UGR) I-bands reportedly shows a weak, teardrop-shaped feature extending roughly 30 arcsec, about 56,000 km, away from the Sun. The coma spans approximately 10 arcsec, approximately 18,800 km, and looks more extended than early July shots. These are preliminary team images highlighted in a commentary, so exciting but awaiting independent confirmation, release. JWST NIRSpec observed 3I/Atlas earlier in August at approximately 3 AU and found a CO2-dominated coma with CO2 H2O8+1 among the highest ratios ever seen in a comet. Water is present but far weaker than CO2 along with CO, OCS, water ice and dust. SphereX mapped the CO2 coma out to 348,000 km, implying vigorous CO2 outgassing on a truly giant scale. That's solid, peer-reviewed spectroscopy. Fresh VLT X-shooter/UVS data report rising NiY emission and incipient CN as 3I/Atlas approaches the Sun, but no Phi lines in those spectra. The authors suggest nickel could be released via low-activation energy processes, for example photon-stimulated desorption or Ni-carbonyl-like chemistry. Not that it's industrial metal. This is real spectroscopy, now accepted for publication. If your gas production is CO2 heavy, solar radiation pressure and solar wind can sculpt a teardrop tail anti-sun, while sunward outgassing gives a fan toward the sun. JWST already shows sunward enhanced emission, so a faint anti-solar dust gas feature at larger scales isn't shocking. The key is, how bright and how dusty is that tail versus the tight sunward glow near the nucleus? Converging evidence. It's a cometary ISO with CO2-rich activity, seen by JWST and SphereX. Nickel and CN lines are real, Phi absent to limits in those VLT data. Open questions. Is the Gemini South anti-solar tail robust across teams' epochs? We need released images plus independent reductions. Dust versus icy grains. The scattering population in the tail halo is not pinned down yet. Morphology. Does the anti-solar tail strengthen as outgassing rises? New deep images from multiple observatories will decide. Chemistry trends. JWST VLT follow-ups. Does Ni continue to soar? Does CN explode closer in? CO2 versus H2O. Does water catch up as heating increases, or does CO2 stay king? Geometry windows. Object goes behind the sun around late oct. Visibility improves again later. Watch scheduling for JWST/VLT/ground campaigns. Bottom line, 3I/Atlas keeps surprising. Chemically and now possibly geometrically. If the anti-solar tail is confirmed, it fits a picture of CO2-dominated activity being sculpted by the sun. I've linked the primary JWST VLT papers and official mission pages below. Check the data yourself and tell me what you think we'll see by perihelion on October 29.